So, hello everyone. Thank you so much for being here. This is the last presentation of the conference. So, today I'm going to be talking about designing for mixed reality at Osmo. And so my name is Tony Aube, and I'm a staff designer at Osmo. I've been working there for around 4 years now. And for those of you who don't know what Osmo is, it's basically a mixed reality gaming platform for the iPad for children. And the way it works, it's super simple, is that we add a reflector on top of the iPad's camera like this. And from there, we can see what's happening on the table. And we build all sorts of puzzle and educational games and applications for children. So we have like the puzzle game, we have the word game also, we have coding games, number games, and so on. So the way it works is very simple. As I said, it's just a plastic mirror that we put on top of the iPad. And from there, we can use computer vision to understand what's happening on the table. So Osmo has been around for about 4 years. We've grown to about 80 employees. And we've been selling in more than 50 countries, and we're being used in more than 30,000 schools. So I think we've been fairly successful. And today I want to break down basically all the design decisions that we've made in the past 4 years, and basically try to understand why these design decisions made Osmo successful, and also talk about some of the lessons learned along the way. So here's how Osmo began. Osmo is the brainchild of Pramod and Jerome, who are the two co-founders of the company. And I really want to mention them because a lot of the super early stuff I'm going to be presenting today was done by them. And I just want to make sure that proper credit is given to them. So the project began when Pramod was at Google working on the technology that scans thousands of books per day. And the idea was very simple. It was to use the same technology but apply it to the iPad. So this is the very first Osmo prototype. As you can see, it's the same idea with the plastic mirror. And from there, it's the idea that you can interact with the iPad using any types of cards or hardware. And so the founder started with this idea, and they wanted to create a real business and a real product around it. So they asked themselves a super important question. Basically, it was, what's the purpose of Osmo? And to me, this is probably the most important question you should ask yourself before you start working on anything. And usually the answer to that question is much harder to define than that you might think. But when you find the answer to that question, it's just going to make the other design decision along the way so much easier. So for Osmo, the purpose, the whole point of doing this is that it's a hands-on product that allows you to interact with technology. So from this understanding came all of the other decisions. For example, this led to the decision on focusing on younger children. Because as you know, it's super important for young kids to be interacting with their hand to develop the key motor skills and hand-eye coordination, all of that. So at the time, there was also, it was about the time where iPads were becoming to be very popular, and parents were starting to realize that this is a really addicting device, and there was this whole problematic of screen addiction. So there was an opportunity to make Osmo a healthy kind of compromise between screen time and healthy real-world play. So this idea of building a hands-on product led to all of the decision of making a product that's for kids, that's educational, and that's fun. Something super important also that the founder realized is that Osmo is a completely new type of user interface. And I mean in the same way of a mouse or a keyboard or a touchscreen, these are all user interface. And while we're pretty able to use a keyboard or a mouse today, Osmo, by the fact that it was completely new at the time, there was not a really strong mental model on how to interact with it. And I think this is the same thing for any type of VR or AR projects. Basically, for most of the user, that's going to be a completely new type of interaction. And thus, it's super important to focus super early on design and user experience. So from here, the founder made 5 key design decisions that, looking back, I believe made Osmo a much more successful product. The first one was to remove the vision markers on the hardware. So as I've just shown, these were the first tiles from Osmo. And as you can see, there's all these small kind of QR codes on the tiles. So the team worked super hard to try to remove these. And as you can see, as soon as you remove them, the product becomes so much more magical and so much more beautiful. And the reason for that is that whenever you work on mixed reality or augmented reality, it's a little bit like making a magic trick. People don't really understand how it works, and that's kind of the way it should be. If you show all of these small QR codes, that's a little bit like a magician revealing its trick, and it's a bit unfortunate. Also, another key decision was to remove the whiteboard. So as you see here, the first version of the game had this plastic whiteboard on the table. And once again, the team worked super hard to try to remove it. And suddenly, the product becomes so much more magical, so much more interesting. It just opens up the play area to the entire table. And this kind of enabled many different new type of interaction. For example, this idea of sliding the tiles on the table. However, the whiteboard was very interesting in the sense that it kind of helped the user to understand that, for example, if a tile is outside of the whiteboard, it's not going to be picked up by the iPad. So if you remove the whiteboard, then you have the problem that it's not so clear anymore whether the tile is within the play area or not. So the way we solved this was with the design of the Osmo base. So as you can see, the base here has two very sharp edges on both sides of the bases. And this kind of naturally, subconsciously communicate to the user the size of the play area. So this is a good example of using hardware design to solve a software problem. Another very important decision was to remove electronics. So a lot of people who come to us, they ask if we've been using, for example, Bluetooth or any types of electronic with hardware. And the answer is no. The only thing that we use is computer vision. And this gives us a super important competitive advantage compared to some of our competitors, such as MakerBlocks, for example. So there's a lot of projects on the market that try to do a similar experience to Osmo, but they use electronics. And this means that the hardware is super complicated and costly to produce and manufacture. And on the other hand, Osmo, all we do is using plastic and wood. So the piece, the hardware, is super cheap to produce. And in the end, we can sell a similar experience for the same price, but our profit margin is much better, which means that we've been able to survive for the past 4 years, whereas a lot of other projects just went silent. Another key design decision was to remove the screen interaction as much as possible. And this goes back to the idea that Osmo is a hands-on product. So it would have been a little bit unfortunate to have this kind of product where you interact mostly with the screen. So, and this is also a great way for us to differentiate ourselves from other products, for example, games on the App Store that don't have a very good reputation among parents. So for example, this is a pizza cooking game, and the way it works is that the character asks you to cook a pizza and you just add the tiles on the hardware. And it would have been very easy for us to add a big green red button on the screen like this that then sends the pizza to the oven. But because we want to stick to the hands-on interaction, we came up with this solution, which was just sliding the pizza on the table, which pushes it on the oven in the screen. And this is just a simple way to keep the children focusing on the core of the experience, which is the table. Another super important decision, and this one is a little bit more of a business decision, is the idea to sell the hardware and give the software away for free. So the way Osmo works is that you can buy the physical pieces in store, both on Walmart or Target or online. And once you buy the game, basically all of the apps that come with that game are completely free forever. And this goes back to the idea of trying to build a healthy product. Because we're being paid upfront for the game, we don't need to resort to all these kinds of microtransactions to try to get more money from the users. So we don't need to do these kind of dark patterns that a lot of other games employ. And this helps us to create a much healthier type of product for children. And this is something that's very dear to the people at Osmo, because a lot of these mechanisms that games for children, that what they use is straight up from the casino industry, and you will never bring a children in the casino, but for some reason children are allowed to use the apps on the App Store, for example, which are exactly the same. So in short, Osmo has no vision markers, no whiteboard, we just open it up to the table, no electronic, we try to minimize as much as possible the screen interaction, and we sell the hardware to put the incentive to have a healthy product. Next, I want to talk about the design process. And once again, I go back to the idea that Osmo is a hands-on product. So whenever we start designing an Osmo game, we always start with the physical pieces, and then we build the software around it, and not the other way around. And something else that's super important is that the hardware must be fun on its own. So no matter what we work with, whether it's Play-Doh or puzzle piece or pencils, we always want to make sure that the interaction is fun on its own, and then we can make sure to build a nice experience around that. Cards are a very fun type of material to interact with. So when you give cards to children, they're going to shuffle them, they're going to throw them on the table, and it's just a lot of fun to manipulate. So that's for the reason why the very first Osmo prototype used this kind of cards. And so this one was another of the very early Osmo prototype. And again, it's a super simple idea. You have musical instruments on the table, and you push them in front of the iPad, and then the iPad is going to play the music. So we tested it with children, and all of the children just hated it. So it was a complete disaster. It didn't work. And the reason why it didn't work is that the children just didn't understand why they couldn't just tap on the screen to make the music play. And this kind of made a lot of sense to us. Like, why go through this whole process of using AI and computer vision and tiles and all of that when you can just tap on the screen and get the same experience? So this led to the third realization, which is probably the most important thing you can keep from this presentation, is that whenever you work on some sort of mixed reality or AR, the combination of the digital and the physical components must be better than the sum of its parts. And this is what led us to the first well-done Osmo prototype, which was the Tangram game. And the idea here is super simple. You have the Tangram puzzle on the screen, and you build the puzzle on the table, and along the way you get some feedback. And when you complete the puzzle, you get some nice rewarding moment, and maybe you get a little bit of score tracking, and then you get the next challenge after that. So I think this was the perfect first game for Osmo, and there's a lot of reasons for this. The first one is that this is super intuitive. I can just show this picture to anyone, and they immediately understand how the game works. And so this is something that I always try to keep in mind when I work on these games, is I try to think of it in terms of a photo, and I ask myself, if I show a photo of the game to people, are they going to understand the interaction? But even more importantly, the combined experience is better than the sum of its parts. And what I mean by that is I could just go to the store and buy a Tangram puzzle with a Tangram book, and I will have a lot of fun on my own. Or I could go to the App Store and download a Tangram game, and I could also have fun. But to me, combining the two is a very good example where the experience is better than the sum of its parts. Basically, this is where the digital and the physical multiply each other. So every time we try to create a new Osmo game, and I think this is the same for AR, we always ask ourselves the question, could we create a better experience that is screen only? Or could we create a better experience that is only hardware? And if the answer is yes to any of these questions, then we're just not going to do it because we know it's not going to be a great Osmo game. Now I want to share a little bit of tips and tricks about designing Osmo games. So the first one is super simple. It's basically paper and cardboard. So whenever we have an idea and we want to try it really, really quickly, what we do is that we just build a prototype using paper, drawing on it, and then we're just going to play it out on the table. Maybe we can bring even some new people to try to experiment with it. And it's just a quick and easy way to explore the idea. The second one, which I think is something that's super important to me, and I use it a lot, is the use of video. So for this one, I'm going to give you a concrete example. So about 6 months ago, Osmo signed a partnership with Disney, and the challenge was to try to make a drawing game that will make drawing fun and accessible for young kids. So we tried a lot of different prototypes, and most of them didn't work out, but this one was very successful, so I'm just going to play you the video.
Anger doesn't like being bald. Can you draw some hair on Anger's head?
Yeah, give me something stylish. Oh yeah, that's it. I can't wait to show everybody. Darn it. This is why I can't have hair.
So what's interesting with this video is that it's basically completely fake. The way I produced this is I just sat down on the table in front of a green screen iPad and I printed out a sheet where I just pretended to be playing the game. And then I brought all of that into After Effects. I just composited the UI, the animation. I did some voice recording with some of the Osmo employees. And ultimately I ended up with a very nice video that I could then show to the stakeholder at Disney or internally at Osmo and just rally everybody behind the idea. And personally, I come from the web and mobile design industry, and in web design or mobile design, you got a lot of awesome tools to create prototype, like InVision, for example, where with maybe 5 minutes of work, you can get a fully working prototype on your phone that you can just test with anyone. Unfortunately, in augmented reality and mixed reality, you don't have any of that. So you kind of need to find clever ways to explore the problem space and communicate your ideas with the team. So to me personally, I think video and After Effects is such an awesome tool because it allows you to show not only the digital experience, but also the real world experience in front of the screen. So this interactive drawing game idea ultimately became Osmo Super Studio, which we just shipped last month. Another idea that I like a lot is what I call Wizard of Oz. So this was another idea that I came up with when working on the Disney game.
Help Dory find her friends. Use the magic pencil to find them.
Woohoo, you found me. So as you can see, this is kind of a Where's Waldo with a mixed reality twist. And I really love this idea, and then I wanted to try it with children to see how they will react to it. But once again, at this time in the project, there was no engineers. It was just me as a designer, mostly working on stuff. So I still went ahead and produced an interactive prototype to try with children. But basically, what's interesting here is that there's no working prototype. The way I did that is I just connected my computer to the iPad, and I was mirroring my Photoshop app into the screen. And I was just looking at what the kid was doing on the table and was trying to match the proper feedback on the screen. And this completely worked. None of the children I tried this with understood that they were not playing a real game. And so to me, this was a very good example of a way to quickly test an idea without requiring any engineering work. If I tried to build a prototype like this using, for example, Unity and computer vision, this will have been probably like a week or two of work only to test an idea, whereas this prototype, which I built in maybe 4 hours, was enough to try out the idea. And so the way I did that is I just used an app called Duet to do screen mirroring and Photoshop on my computer. And ultimately, this look and find game became Osmo Detective, which is another game that we've just shipped actually last week. So I think the lesson here is to always try to find low-cost way to explore your idea and communicate your ideas with the team and the stakeholder. And also try to avoid going with engineering as much as you can, because engineering is very time-consuming. And in this space, you need to iterate very quickly to find something that works. And usually, if you can bypass all of this, it's going to go much faster. Another thing that we use a lot internally at Osmo is QR codes. So earlier on, I showed how we try to hide the QR codes from the hardware, but when we're prototyping our games, we just embrace it. So this is an example of a music game, and as you can see, we just printed some like visual codes that we just stick on a straw and some like piece of hardware, and from there, it's very easy to build working prototypes. So the way it worked is that we just had our engineers build kind of a support for these different type of QR codes like these ones. And then it's possible for any engineers to just implement the game with Unity using this code without having to do any deep computer vision or AI work. So the lesson here is to try to build the infrastructure that's going to help you iterate as quickly as possible, even on the engineering side. Finally, I want to talk a little bit about playtesting. I think playtesting is super important. And that's something that we do very nicely. I think at Osmo, we playtest every week. So every Thursday, no matter what I'm working on, there's going to be children coming into the office, and I can just try out any idea that I have to make sure that it's working nicely. So something that's really nice about that is we have someone internally who's the coordinator who's going to take on the whole logistics of making these playtests happen. And so we reach out to parents on Facebook and we just communicate with them. And we make sure there's a constant stream of children coming to the office every week. And from there, we can just test the game, and we realize that like plenty of stuff that doesn't work, like children cheating like this to progress faster in the game. And we also record all of these playtest sessions, and when they're playtesting, everybody can just tune in on their computer to watch the playtest, and everybody does it because it helps everyone from the team to build empathy for the problems and for the users. So playtesting, I think something that's super important to understand is playtesting should not be an event. It should not feel stressful. It should not feel like something that's complicated. It should be something casual that you just do every week. And the best way to do that is to remove the burden of figuring out the logistics from the creative team. And also something that's super important to me is everybody should playtest. The designer, obviously, but also the engineers, the project manager, everybody should try to build empathy to the design problem and try to figure a way to solve them. And finally, try to record everything. It makes it so much easier to go back to the video and watch where the whole thing breaks down. Finally, I want to talk about some of the mistakes that we've made over the time, and more particularly, the first video that we tried to ship the game with. So this video was a complete disaster. It cost something like $30,000, and we never used it. And as I'm going to be playing the video, I want you to try to understand why it wasn't working. So side note, when we launched the product, the company was called Tangible Play. And at the very last minute, we swapped it to Osmo, so it was kind of a crazy time. So did anyone figure out why the video wasn't working? Yes?
It wasn't working because, first of all, the feedback was right on the actual table instead of on the screen.
Mm-hmm.
And also the girl looked so sad.
Yeah. That's true, we got this comment as well. Yeah, I think the big problem with the video is basically we just never took the time to explain how it works. So when we tried to show it to parents, they just didn't even understand the product. And there's a couple reasons for that. The first one is that nowhere in the video did we show the iPad. I think we show it like twice for like 1 second at these two moments. And one time it's in the back, super hidden, and the other time it's super zoom in, so you can't even recognize that there's an iPad in the video. And the second problem was that we tried to convey the magic of Osmo, and the way we did that was by adding all of this kind of like weird visual effect on top of the video. So that was kind of the way we poorly tried to communicate the magic of experiencing Osmo for the first time. And that didn't work at all, because when we showed the video to parents, for example, they thought that the pieces, when you connect them, they actually make lights effect like this. And at first, this kind of blew us away, but this was also a super humbling experiment for us, because we understood that, like, when you work on things on like mixed reality or augmented reality, for most people, like, they've never seen something like this before. So whatever you show them, they're just going to assume that's the way it is. So it's super important to think about this and be super careful about the way you communicate your idea and your projects. So what we did is we went back to the drawing board and we reshot the video another time, and this one was so much an improvement over the last one. So as you can see in the video, we really take the time to break down how the product works, how to build the setup. We show the mirror. We also show the hardware. We show that this is an iPad game, so you see it tapping on the screen. And when the girl is playing, you see, like, we really take our time to show how to build a tangram, and we also focus on the iPad showing the feedback from the screen. And the lesson here was that, you don't need to add any type of like special bells and whistle. You can just break down how the product works, and if the product is good, it's going to speak for itself. So I think the lesson here is just whenever you come up with something that's completely new, that hasn't been done before, it's super important to communicate to your consumer how it works and why it worked that way. And also let the product speak for itself, so you don't need to add like crazy things or crazy visual effect. Just show it like it is and it's going to work. And finally, it's super important when working on these kind of projects to always try to communicate with photo and video. So mixed reality is as much about the digital component as it is about the real world. And I find that photo and video are just the best way of communicating that. So in conclusion, today I've shown a lot of different tips and tricks for designing for Osmo. Some of the lessons that I've shared is to always start with the hardware and build the software around it, not the other way around. Hardware must be fun in itself. If not, then no matter how much software or game mechanics you add on top, it's just not going to be as fun. The combined experience must be better than the sum of its parts. That is super important. If you can come up with a better screen-only or physical-only experience, then it's not worth trying to do a mixed reality experience. Video is your best friend, both for exploring the problem space, also about communicating the problem, the project to your teammates and also to the stakeholder, and also about communicating the idea to the consumer as well. Playtest every week. Try to make playtest a casual thing. It shall not be stressful. It shall not be burdensome. And finally, let the product speak for itself. You don't need to add crazy visual effects to make it more interesting than it is already. And finally, always start with the purpose, like why are you going to work on this? And finding the answer to this question is pretty hard, but once you have it, it's super easy. It just helps with solving all of the other design decisions that are going to come up later down the road. So thank you so much. Is there any questions? We have 5 minutes. And there's a mic here if you want to ask questions. Yeah, we work with teachers. We have a lot of people that interact with us. They ask us for different games, and we always try to build the games whenever possible that try to match the curriculum of elementary schools. Yes. And also I want to mention we have a SDK, so if you ever want to try to build for Osmo, you can just visit that link, and we're super collaborative and we can help you achieve your ideas using the Osmo platform. Thank you so much.
I did have just one question, which was the iPad has changed quite a bit since you first started. Has any of the camera improvements or anything like that changed the code you've needed to write or anything like that?
So yeah, the camera has improved a lot, which is great because right now we support all the way down to iPad 2, but the camera on iPad 2 is extremely horrible, so it's a little bit of a miracle that we can make it work. So every year our works become easier thanks to the new camera and also all the new technology, for example, that Apple is making like ARKit. And however, the design of the iPad have changed a little bit over the time. For example, they just came out with a completely new iPad, which has the camera is much higher up. So that might cause some problem, and we're going to need to solve that on the hardware side of things. But we're also constantly trying to improve the hardware to make it work with as many devices as possible.
Mm-hmm. Have you had to make any of the hardware obsolete?
Not now, so I still have the first version of the hardware and it still works, but probably for the future iPad, which have a much lower bezel, we're going to need to come up with something different. And yeah, thank you so much.